So today we are going to discuss about correlation and convolution. So in the case of linear spatial filtering methods, we have to understand what is correlation and what is convolution. So correlation consists of moving the center of a kernel over an image and computing the sum of products at each location. As you can see in the figure that this blue window representing the kernel and the center of this window is representing the kernel origin, and this one represent the image, and this is the zoom version of this one where this will represent the filter or kernel, and these are the weights corresponding to these pixels, and this one is corresponding to the subsection of the image that is behind this kernel. So if we want to write a correlation in a one dimension, then it can be represented as g of x is equal to summation of w of s, which is the weight of the filter, into f of x plus s, where s varies from minus a to plus a. So in this figure, you can understand the correlation and convolution. So as I already told about correlation, so the convolution, in the convolution, the mechanism of convolution are same except the correlation kernel is rotated by 180 degree. So now you can understand from the figure that it shows the one-dimensional function, this one, and a kernel of size 1 cross 5. So you can say that s is equal to 5, or it varies from minus 2 to plus 2. Now in the case of correlation, what we have to do? We have to multiply w with f, and now varies from minus 2 to plus 2. So for this one is a minus 2, minus 1, 0 position, and this one is 1 and this one is 2. And this one is a function. So as you can see that there is a no element or pixel value here. So we have to artificially put the 2 zeros here. So this is known as zero padding. So now we put artificially 2 zeros here and 2 zeros here. So now we are going to multiply this kernel weight with the function, and then we are going to add all those weights. So 1 into 0 is 0, 2 into 0 is 0, now 4 into 0 is 0, 2 into 0 is 0, 8 into 0 is 0. So summation of all these values will become 0. Now this point will move one shift in the rightward direction. So now it will become 1 into 0 is 0, plus 2 into 0 is 0, plus 4 into 0 is 0, plus 2 into 0 is 0, plus 8 into 1 is 8. So now this pixel position changes to 8. Similarly, if we shift 3 position, so now 1 into 1 is 1 into 0 is 0, 2 into 0 is 0, 4 into 1 is 4, plus 2 into 0 is 0, plus 8 into 0 is 0. So now the overall summation is 4. So after 8, then we move 2 here, then we move 4 here. So now this will become 8. When multiplied with 1, this position will comes out to be 8. Now 2 will multiply with 1, so this position will become 2. As you can see in this figure that when 4 is multiplied with 1, this position will become 4. Similarly, it will move on. And finally, when it comes out to be here, again 0. So 0, 0. While in the case of convolution, we have to rotate the filter by 180 degree. So after rotating this filter W by 180 degree, it will become 8 to 4, 2, 1. Now we have to perform the same process as we perform on the correlation. So now we are going to multiply this one with this function and add all the elements after the multiplication. So there is no element, so we have to artificially put the 0, which is also called 0 padding. So now 8 into 0 is 0, 2 into 0 is 0, 4 into 0 is 0, 2 plus 0, 2 into 0 is 0, 1 into 0 is 0. So overall summation is 0. Similarly, when move in this direction 1, so 8 into 0 is 0, 2 into 0 is 0, 4 into 0 is 0, 2 into 0 is 0, 1 into 1 is 1. So overall summation is 1. So now second place is 1. If we move in the more in the this direction, for example, now we move position after 3 shifts. So 4 into 1 is 1, rest elements will become 0. So third position is 4. So a similar kind of concept can be introduced in a 2-dimension. This way. So this one is an original figure in a 2-dimension, and this one is the size of the filter. Now what we have to do, we have to multiply this kernel with this function. But before multiplication, as when the center of this kernel we move to this origin, then these elements, for these elements there is a no pixel value, and for this one, so we have to artificially put the 0, which you already known is that they are called as 0 padding. So in that case we have already put the zeros in the left and right and in the top and bottom. So for a kernel of size, we pad the image with minimum of m minus 1 by 2 rows of zeros at the top and bottom and n minus 1 by 2 columns of zeros on the left and right. In the present scenario, the m and n are equal to 3. So 3 minus 1 divided by 2, which is 1. So 1 row in the top and 1 row in the bottom. Similarly, n is also 3, so 3 minus 1 divided by 2 is 1. So 1 column on the left hand side and 1 column on the right hand side. Now we can perform a correlation here. So for correlation in a 2-dimension, we can represent that W, which is a kernel function in a 2-dimension. This represents the weight of the kernel, and this represents the function or image function. So here the kernel size is twice of A cross twice of B. So now S will vary from minus A to plus A, and T is vary from minus B to plus B. Or in short, we can write G of X comma Y is equal to W correlation F. This symbol represents the correlation. Now we are going to perform a correlation with an correlation. So in this we are going to choose a filter and there is an input image. So we are going to correlate this kernel with input image. So since we are performing a correlation, so we do not have to rotate it. The rotation of 180 degrees is required in the case of convolution only. So as you can see, this is a filter of weight. At the center element we have weight 2 and diagonal elements are 1 and 1, and here minus 1 and plus 1, and the neighboring element are plus 1, minus 1, minus 1 and 1. And this one is an input image. As you can see, the size of the filter is 3 cos 3. So we have to pad a 0 rows at the top of this image and at the bottom of this image. 1 0 row at the top of this image and 1 0 row at the bottom of this image. And n is also 3, so we have to put 1 column on the left hand side and 1 column of zeros on the right hand side. So before performing a correlation, we put a zeros here. So this is known as zero padding. Now this center of this kernel is placed on the origin of this one. So now 2 is placed above just this. 2. So now 2 into 2 is 4. And here because there is 0 element, so we do not have anything. 0 into 1 is 0, 0 into minus 1 is 0, 0 into minus 1 is 0, 0 into 1 is 0, and 0 into 1 is 0. Now 2 into 2 is 4, minus 1 into 1 is minus 2, 1 into 2 is 2, and 1 into 1 is 1. So, and now the summation is 4 plus minus 2 plus 2 and 1. So that is equivalent to 5. So 5 is going to replace this 2. Now we are going to sweep this kernel over the entire image. So now the position of this 2 will be shifted to this place. So now 2 into 2 is 4, 1 into 2 is 2, minus 1 into 2 is minus 2, 1 into 0, yeah, this element is okay, 1 into 2 is 2, 1 into 1 is 1, 1 into 3 is 3. So here because there is a 0 element, so we are not going to consider this one. So 4 plus 2 6, minus 2 is 4, plus 2 6, 7, and 3 is 10. So total 10 is going to be replaced this element. Similarly, if you are going to scan these images, we are going to fill this complete image with the product of this kernel and this image. So after complete correlation, we are going to get this output image. Now, what is convolution? That is similar to correlation, only we have to flip the kernel by 180 degree. So g of x I comma j, which is an output of convolution of w I comma j convolving with input image, where w is the corresponding to filter function, and f of I comma j is corresponding to input image. So now here the size of the filter is k cross k, so s will vary from minus k by 2 to plus k by 2, and t is also varies from minus k by 2 to plus k by 2, and w is the function of ws comma t is a function of filter. And now since we have to rotate the filter by 180 degree, or we can rotate the image by 180 degree, the same the convolution will give the same result. So f of I minus s comma j minus t. Now if filter is symmetrical, then the convolution is equivalent to correlation. Now before performing a convolution, we are going to rotate this kernel by 180 degree. So now if we are rotating this one by 180 degree, this will becomes 1. This minus 1 we rotated by minus 180 degree this way. Minus 1 rotated by 180 degree, it will come here. Now 1 is going to be rotated by 180 degree, so it will come here. 2 is rotated by 180 degree to this one. Minus 1 rotated by 180 degree, this will come here. 1 is going to be rotated by 180 degree this way. 1 is going to rotated by 180 degree, and this one is going to be rotated by 180 degree. Now we have to perform a similar correlation with this filter with an input image. Similarly, now this is a rotated version of original filter function by 180 degree. So 2 will be multiplied with 2, since this 2 is going to be placed at this position, and here we have to put zeros. So there is a 0 padding. So 2 will multiply with 2, that will give a 4. 1 will multiply with 2, that will give 2. Minus 1 will multiply with 2, this will give minus 2. 1 will multiply with 1, this will give 1. So now 4 plus 2 6, minus 2 is 4, then 1 5. Similarly, we are going to scan this filter throughout the image, and we are going to get an output image. The only thing we have to remember is that before proceeding convolution or correlation, we have to zero pad. And the value, how you are going to get a zero pad? You have to put m minus n by 2 number of rows on the top and bottom and number of columns on the left hand and right hand side is equal to n minus 1 by 2, where m comma n is the size of the kernel. And if the kernel is symmetrical, then convolution and correlation are equivalent. So in the case of deep learning, most people call for a two-dimensional imaging convolution neural network. Basically that is a correlation, but since the filter is always symmetrical, so we called it convolution neural network. You can also call it correlation neural network. So finally we are going to get the convolved image. So some review questions are: what is the difference between the correlation and convolution, and when correlation and convolution yields the same results? These are some references. Thank you.